In this video, I'm going to answer the question that I know you've always wondered about, which is, why is it that giraffes have the tightest ankle skin of any creature in the animal kingdom? All right, I'll explain it. So I'm going to do my best to draw a giraffe here. Those of you who know me know that I really struggle with my artistic abilities. So let's see what I can make happen. They have these two little nubs up here, I know that. And then there's like something like this and like this. Yeah, and then like this. Right, kind of like that. I feel like it looks a little bit more like a brontosaurus than a giraffe, but you get the idea. Maybe put a couple spots in there. Okay, so let's assume that that giraffe has a heart. Right over there, okay? And because giraffes are as tall as they are, there's going to be a huge hydrostatic pressure difference between the heart, right? Between the pressure that the heart is creating when it beats and the pressure down here at the feet, okay? So specifically the ankles. Now, we all remember this equation from physics and chemistry, right? This hydrostatic pressure equation, which says the pressure anywhere in some fluid is equal to the original pressure at the top plus the density of the fluid times gravity times h, which basically just means that the pressure here is equal to the pressure at the heart plus this is really the weight of all the blood between the heart and the ankle. All right? Now, you can imagine that because there is all this extra pressure, there's going to be a fluid pressure that's going to push out at the ankle, which is going to require this giraffe to have extremely tight ankle skin to hold the ankle together, right? So, all right, let's figure out what should this pressure be. Okay, now I will go ahead and tell you, this has been measured, that the pressure, the systolic pressure at the heart of a giraffe is 300 millimeters of mercury. Okay? But, of course, this equation requires that we do everything in SI units, so we got to first convert that into SI units, which is Pascal, right? And I will tell you that there are, how many? 133 Pascal in 1 millimeter of mercury, right? Which means that this systolic pressure at the heart is actually going to be 39,900 pascals. Okay, what else do we know? Well, we know that the density of blood is roughly the density of water, right? Blood is mostly water. So we can just approximate this as 1,000 kilogram per meters cubed, right? And gravity is, of course, 9.8 meters per second squared. And the height is, of course, the 2 meters, right? The roughly 2 meters that the feet are below the heart of the giraffe. So I'm going to put 2 meters there. Okay, so let's figure this out. We know that pressure then is going to be 39,900 plus rho, 1,000, times 9.8 times 2. Okay? Put this in your calculator. The pressure that I get at the ankle, we can go PA for P ankle pressure, is going to be about 59,500 Pascal. All right? But again, this isn't very useful because this is in Pascal, and we usually measure blood pressure in millimeters of mercury, right? So we know that to get from Pascal to millimeters of mercury, now we got to do the opposite. We got to divide by 133 pascals per millimeter of mercury, which means that the pressure at the ankle of this giraffe is going to be 447 millimeters of mercury, which when you think about it is nuts, because what is the average systolic pressure of a human? Well, if you're too much over 120 millimeters of hydrogen or of mercury, you are in rough shape, right? But this poor giraffe has almost 4 times that level, right? 4 times the pressure in the little giraffe's ankles, which explains the reason why these giraffes have to have tighter ankles than any other creature in the animal kingdom. And now you know.